We end tonight with the clearest pictures yet of Neptune.
And speaking of space, NASA's James Webb Telescope captures the clearest look at Neptune's.
At the farthest reaches of our solar system, where sunlight is faint and the known celestial bodies taper off into icy silence, the James Webb Space Telescope has made a discovery that has shocked the scientific community and captivated imaginations around the world. The impossibility of what it has revealed lies not just in its distance or mystery, but in how it rewrites the rules we thought were immutable. Through the veil of darkness beyond Neptune, the JWST has peered into a region astronomers have long considered largely unchanging, a frozen domain of small, ancient and quiet bodies left over from the birth of the solar system. But what it found there breaks that silence wide open. Before we start, smash the like and subscribe buttons for more updates. Using its near-infrared camera NIRCam, the JWST focused on the trans-Neptunian region, a realm populated by Kuiper Belt objects, KBOs, and other icy dwarfs. It was while studying a dim, irregular object presumed to be a KBO that the telescope's sensors detected anomalous energy readings. The object, initially cataloged as a routine rock, began showing spectral characteristics that didn't match ice, rock, or any previously observed compounds. Instead, the telescope picked up something astonishing: an active energy signature, more specifically, bursts of mid-infrared emissions that pulsed in regular intervals. These readings suggested internal heat and a source of energy, something that shouldn't exist that far from the sun, where temperatures drop to near absolute zero. Closer analysis revealed a subsurface geological process, a kind of internal activity indicating the presence of a heat source, possibly even cryovolcanism. But more bizarrely, the spectrum suggested the possible presence of complex organic compounds interacting with unknown elements. This wasn't just a frozen body, it was something alive in a geological or chemical sense. To detect signs of change, movement, energy, reactions on a body that was thought to be inert for billions of years stretches our understanding of thermodynamics and planetary science. The implications began stacking almost immediately. What makes this find so extraordinary is its apparent isolation. Unlike moons like Europa or Enceladus, which orbit massive gas giants and can rely on gravitational tugging to drive internal activity, this object exists alone in a sparse region, far from any planet capable of influencing its internal workings through tidal forces. With sunlight negligible and no nearby planetary body to exert tidal heating, the object's energy must be coming from within. This either implies a radioactive core that has somehow retained heat for billions of years without dissipating, or a new form of energy generation entirely unknown to science. The detection of such a process challenges the very assumptions made about thermal dynamics at such distances. The physical structure of the object also defies expectations. The JWST's high-resolution instruments captured faint surface details suggesting something more sophisticated than a lump of ice and dust. Some surface ridges resembled the patterning of tectonic activity, albeit in slow motion. Fissures appeared to have vented material recently, given their albedo and thermal emission signatures. These weren't signs of an old impact or a brief collision, they were signs of current, ongoing processes. The temporal resolution captured by the telescope indicated that these weren't one-off bursts but recurring emissions, suggesting cycles of geological activity, a heartbeat in the void. Adding another layer to the mystery, Webb detected electromagnetic patterns around the object that hint at a magnetic field, weak but discernible. Such a magnetic presence could only occur if the object had a partially liquid interior with conducting material, like a metallic core or saltwater ocean. For such a small, distant object, that idea was previously dismissed outright. No model of solar system formation accounted for this, yet the data is consistent, undeniable, and vivid. The magnetic fluctuations, along with heat signatures and spectral emissions, point to a body not merely surviving at the edge of the solar system, but thriving in its own alien rhythm. The implications of such a find reverberate across multiple disciplines. Planetary formation models may need to be updated to account for a class of bodies capable of retaining or generating energy long after the initial formation era. This could mean that the processes which birthed the solar system left behind more active remnants than previously believed. If this object isn't unique but simply the first of many such bodies to be uncovered in the Kuiper Belt or even the Oort cloud, then the outer solar system could be much more dynamic than previously imagined. Entire ecosystems of geological or chemical activity could be awaiting discovery, hidden behind layers of frost and assumptions. Even more tantalizing is what this means for astrobiology. The spectral data indicating complex organic molecules is not just a footnote, it's a headline. These compounds are considered precursors for life, the chemical alphabet from which biological sentences can be formed. If such chemistry is happening spontaneously in the cold, dark reaches of the solar system, it speaks to a universality of organic development. Life, or the ingredients for life, may not be confined to warm Earth-like planets. Instead, it may be embedded in the farthest and coldest regions, awaiting only the right spark. The notion that heat and sunlight are prerequisites for biological complexity may be outdated. Here, in a place never touched by warmth, complexity is forming. Another fascinating layer is the sheer improbability of the discovery itself. The object was never targeted intentionally for groundbreaking analysis. It was part of a broader survey intended to catalog KBOs and refine orbital data. The chance alignment of observation time, angle, and infrared sensitivity allowed this discovery to occur, raising questions about how many other impossible objects are quietly existing beyond our gaze. The JWST, with its unprecedented sensitivity, is revealing not just distant galaxies, but anomalies right here in our solar neighborhood. Anomalies that may be as significant as anything discovered in deep space. The object's orbit is another riddle. It follows a highly elliptical trajectory that occasionally brings it into the gravitational whisper of Neptune. But for the most part, it drifts alone in a region few spacecraft have visited, and fewer still have observed in such detail. Its motion, however, revealed something even stranger. It's accelerating slightly, too subtly for most instruments to detect, but just enough for the JWST's precise calibrations to note. This deviation isn't explainable by known gravitational forces alone, suggesting the influence of either an internal mechanism or, more speculatively, an unseen object exerting influence from even farther out. This has reignited discussions about the elusive Planet 9, a theoretical massive object that could be distorting the orbits of trans-Neptunian objects. If this discovery acts as a beacon drawing our attention outward, it's because it reveals not just one anomaly, but the possibility of an entire uncharted frontier of science. The JWST's detection tools, its ability to discern subtle thermal and electromagnetic variations, have opened a new layer of investigation into planetary science. This is not simply an extension of what we knew, but a leap into the unknown. The current models of how celestial bodies evolve over billions of years in isolation are insufficient to explain what we are now seeing. Something is missing, and this object may hold the key. Scientists are now racing to reanalyze data from past missions, including Voyager and New Horizons, looking for overlooked signs of similar activity. If even a handful of KBOs share these features, it could indicate a widespread phenomenon. And if that's true, the idea of habitable zones may need to be redefined, not by distance from a star, but by internal activity, chemical potential, and unknown mechanisms of energy retention. The concept of where life could exist has always been hemmed in by terrestrial biases. But now, with the JWST's discovery, those walls are crumbling. Life, or the seeds of life, might be growing in places we thought were barren. Another mystery that continues to unfold is the object's apparent interaction with interstellar particles. The JWST picked up an unusually dense envelope of dust and energetic particles surrounding the body, far denser than what would be expected at such distances from the heliosphere. This cloud appears to be reactive, possibly influenced by electromagnetic processes tied to the body itself. It's not just a passive shell, but a dynamic envelope interacting with solar and possibly galactic cosmic rays. The complexity of this interaction suggests the body is not simply drifting through space, but shaping its environment, however subtly. As more data flows in, what was first seen as an unremarkable speck of ice is emerging as one of the most important discoveries in the solar system in recent memory. Its isolation, activity, composition, and behavior defy every classification previously applied to distant objects. It is not a comet, not an asteroid, not a dwarf planet in any traditional sense. It may represent a new class of celestial object, one that bridges categories or requires an entirely new one. The scientific lexicon is struggling to catch up. The discovery also underscores the vastness of our ignorance when it comes to the outer solar system. For all the missions to Mars, the robotic landers on comets and asteroids, and the probes to Jupiter and Saturn, we have barely scratched the surface of what exists beyond. The JWS, although not designed primarily for solar system exploration, has demonstrated that with the right tools, even casual observations can overturn decades of assumptions. It challenges the way we allocate resources, prioritize missions, and even define the boundaries of planetary science. What lies beyond this object is now a matter of urgency and curiosity. Its implications ripple outward like gravitational waves, pushing at the edges of what we thought was knowable. Scientists are already planning targeted observations using JWST's successors, ground-based observatories, and even theoretical mission profiles that could one day visit such objects up close. The possibility of sending probes to investigate these newly dynamic bodies has moved from speculative to urgent. In all its magnitude, this discovery serves as a powerful reminder that the solar system is not a closed book, but a living manuscript, constantly evolving, occasionally offering up surprises that demand we rethink the entire narrative. The edge of the solar system was once imagined as the solar graveyard, a place of ancient frozen debris. Now it appears to be something entirely different, a domain of hidden fire, slow storms, and chemical awakenings. The James Webb Space Telescope, in its distant gaze, has cracked open a door we never knew existed. Through that door, we are seeing not just the edge of the solar system, but the edge of human understanding. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb's discovery? What do you think it found? We want to hear from you. Thank you for watching, and see you next time.